be looking at the 2015 US Open Silver question, Bessie's birthday buffet. So in this question, Farmer John has let Bessie eat grass in his fields, and in every one of his fields, he's going to have a certain quality. So what's going to happen is if Bessie eats a grass patch with a certain amount of quality, then she is no longer going to eat any other patches with a lower quality. So every time she eats something with certain quality, she's going to accumulate energy. And what we want to know is we want to know the maximum amount of energy that she can get. So let's go look at the algorithm for this question. So the main way we're going to solve this question is going to be by realizing that this is a graph question. And so what we're going to do is we're going to combine graphs with DP. So if we have barn 1 or field 1 being here and field 2 being here, what we can actually note is the total amount of energy it takes to reach and go from field 1 to field 2 is going to be the minimum amount of edges times the value of E. And so what this actually turns into is it turns into a BFS question. So the way we're going to do this question is actually going to be a BFS. So we're going to loop through every value from I to N. We're going to do a BFS. So assuming in this case this is I, then we would find the minimum distance to all of these nodes. And then what would we do is we would loop through. And what we're actually going to do is we're going to have a second value j. And so what we're going to do for this value j is we're basically going to check the value that I reaches. We're going to check their distance and see whether or not it's plausible. And if it is, then for the value of dpi, we're actually going to make it the max of the value of dpj, assuming j is less than I, so this value already exists, minus the energy it takes to reach and go from I to j. And so what we're basically going to do is we're going to build upwards, and every time we add a new one, we're going to check the previous values, check the distance between, and for the transition, if I already know the value of dpj, then the value of dpi would just be the value of dpj minus the distance plus the value of dpi field. So let's go look at the program for this question. So the first thing I'm going to do is I'm going to create my data structures, and I'm going to also define two things. I'm going to have f and s as first and second, so anytime you see .f or .s, it just means .first or .second. So I'm going to read in my input, and so I'm going to resize the value of patches, which is going to be all of the fields or patches, and I'm going to read in the input so that I read in patches I.first and patches I.second, and I'm going to create an adjacency list because we're going to be using a graph. So the next thing I'm going to do is I'm actually going to sort the patches. So I'm going to sort my patches, and then what I'm going to do is I'm actually going to create my DP array. So I'm going to create a vector of long longs here, create my answer, and then I'm going to loop through all of the patches. And so when I loop through every time, I'm going to do a BFS. And so this BFS function is going to be pretty standard. It's going to be void BFS, and for every value, so for every value I here, we're going to do a new BFS. And so with every new BFS, we're going to have a new distance array. So I'm going to reset my distance array, and I'm actually going to use a queue. So I'm going to actually keep going until my queue is empty, and this is a pretty standard BFS. So I'm just going to loop through all of the neighbors of my node after popping it. I'm going to check to see whether or not it's already been visited, and if not, then I'm just going to push it. So at the end here, we're going to have our distance array, which is going to tell us the distance of all of the items or all of the fields from I. And so once we finish this BFS, we're going to loop through all of the values j less than I. Because these numbers are smaller than I, they're already going to exist. So we're going to check the value of dp patches j, and this is going to give us the amount of energy we have at patch j, and we're going to subtract the distance between the two. And once we've subtracted the distance between the two, we can make the maximum of dp cur or dpi, the maximum of itself, and the amount of energy we get, which would be the amount of energy here minus the distance it takes to go from patches j to patches I. And then we're going to add the current amount of energy on patches I. So we're just going to assume Bessie is going to eat the grass and gain the energy of Patch's eye. And then down here, we're just going to make our answer the max of the answer in DP curve. And at the very end, we're going to output our answer. And that's the end of our program.